we've built an empty database. We've digitized contacts and made polygons. We've digitized strike and dips. We've digitized key beds. We've checked topology. The next step is to complete the non-spatial tables in the map. Let's go look at our recipe here. GeMS prescribes 3 non-spatial tables that are essentially internal metadata. A data sources table that tells where data describes where data comes from, a description of map units table that describes the map units, and a glossary that defines a number of values, type values, confidence values used at many points in the database. We're not going to do the DMU. That's done in the next exercise. But let's fill out the data sources and glossary table for this map. First thing to do is to add the tables. Oh, we don't want, excuse me, to the map. And then let's go open one of them. And the table is partly filled because the GeMS schema uses some terms everywhere that need definition, and it's built into the database, the empty database. Let me get a little bit smaller. However, we know that we have some other sources for the data in this map. In particular, there's John Whetton's OFR. So we need to edit this. And now we can stick in the source, but typing into these fields is a pain. Very difficult to do accurately and well. And so what I've done is typed up some data sources externally. And I can take this, I can copy it, go into this field and paste, and there it is. For data sources, especially when we digitize, it's nice if we include some notes about who did the digitizing, when, and what, if any, they have added to the data set. And in particular, I've attributed a number of confidence values that have very little definition in the source data. They're my judgment, and that should be recorded. So let's copy that and put that in the notes field. And there's an optional field or an as needed field for the URL. This report is available on the web. So let's put that in here. And we need something to call this. And one thing we could call it is data source number 1. It's the primary data source. That works. Any number of tokens are possible. GeMS is set up to use very short text tokens or very long ones that are globally unique identifiers. The only important thing is that within any given database, these IDs need to be unique. We're also going to stick in a few other sources, and I'm just going to stick them in here for now, right, because I can. We're going to use the glossary of geology as a source for some definitions. And that we're going to describe here. We're not going to use it as is. I chose to modify some of the definitions. And so this is modified from Glossary of Geology. And I think I'm going to stop right there. We can close this, save our edits, and move on to the glossary table. And again, it comes pre-populated with a couple of terms. We want to add some more. We know we have type contact in here that needs a definition. We know we have type bedding. And my first inclination is to go to the Glossary of Geology and get definitions for these things. So let's do that. And here's a picture I took on my cell phone yesterday of my trusty Glossary of Geology. I opened it to contact. And I find the definition, number A is one that's relevant, is unsatisfactory because there's not a single contact on this map, the part we digitized, that meets this definition. All of the contacts are between rock and deposits or between deposits. There are none of them that are rock to rock. So we need a different definition. And I'm really lazy. So rather than write one from scratch, I went to the last map that I worked on and took the definition out of it. And there we defined a contact, so a surface that separates two map units. That is not a fault. And the source for that was USGS SIM 3443, which we're going to put that as a shorthand. We now clearly have a need for another data source for that there. And then we can go to the other thing we have, bedding. And I like the Glossary of Geology description fairly well, but not quite, so I modified it. I also prefer to modify these definitions as I'm concerned about copyright issues if we wholesale copy and paste out of the Glossary of Geology. So there's bedding. And that's going to be GOG 5th edition modified. We now have a need for new data sources entries. And GOG5M. We need SIM 3443. GOG5M is here already. SIM 3443. Got a long title or a long reference. It also has a URL. And we need the token that defines it. Now, I think we've actually got this fairly well under control. We've filled out our non-spatial tables. We've got our spatial stuff done. Oh, we left some fields unpopulated. Let's go through these here. Those open orientation points. There's a bunch of points in here, and none of them have a confidence values or a data source, orientations, data sources. So let's step through here. All of these things come off this map, and we decided this map is not that well located on its own. If it were a clean, scale stable 24,000 map, then 24 meters would be the right answer for LCM. It's not, so let's use 30. Identity confidence. I trust that John Whetton thought everything that he said was bedding, with no question, or he would have told us so. So that's certain. My experience, having used a compass for many years and having taught field camp and having students test themselves to see how well they can measure orientations, is that a well-yielded compass can routinely achieve 2 or 3 degrees of reproducibility. And if we go for 5, we're certainly including the answer here. Plot at scale is the denominator at the scale smaller than which you shouldn't plot this thing because the symbols get too crowded. This map is not crowded. I'm gonna leave this. We'll run a script later to calculate that. Station ID, these things don't have stations. Map unit, we could populate that right now. All of these are inside unit TCS. More typically, They're inside many units, and we would intersect the orientation points feature class with the map unit polys feature class and fill out map unit that way. Location source is from the map we just digitized. And the orientation source is the same. No notes on these. Orientation points ID, we're going to calculate with a script in a few minutes. And PT type is actually, we're not going to use it. It was a convenience for translating data from a la carte. So we can say that's done. We can go to map unit lines and do some of the things. Data sources populated, existence confidence, we're good there. Contacts and faults. Well, this will open up the contacts and faults attribute table. Everything's got a type, it's got an is concealed valued, has an existence confidence value, identity confidence, location confidence meters. We are good except for the data source ID. And I'm going to stop here. These three lines, the neat line, we did not get out of John Wetton's map. So that's going to have to be something else. The rest of these all came from the Chewacum Force Southeast quad. Those are that. And we have gone through, map unit polys. Let's open that. Identity confidence, nothing was queried. So these are all certain. Data source ID was again and again, P-type is a convenience for translating from a la carte, and we're not going to use it here. At this point, the next step is to calculate the ID values for all these features. Open the GEMS tools and go to set ID values. Let's make sure this is. We don't want to reset our data source IDs. We like what they look like. And that's done. We can see what happened by opening up, say, one of these here. Go over and there. This is populated. And it will be that in all of the tables in here. Now, probably we didn't get everything. And typically, we run the validate database script repeatedly to find out what needs polishing, what little holes need filling, what needs fixing. It's not something you do just at the end of the process, but oftentimes in building the database. So we're going to stick in, again, our Chewacum Force Southeast database. And let's leave the topology checks in. There's an option to skip them because they can take a long time. And if you're trying to figure out which tables need filling, that's a nuisance. We're not going to delete any unused rows, although we could. And we don't need to refresh the geomaterial dict. That's an issue if you're working with an older database being brought up to the current version of GEMS. This script does a lot of work. It's about 1,000 lines of code, and some things it checks twice, both at level 2 and at level 3. It brings an answer back for levels of compliance to the GEMS standard. The level 1 is basically you're in a GIS with no expectations of what field names are or feature class names. Level 2 is basically have you got your contacts and polys and your map unit polys and your contacts and faults right. Level 3 is if you've crossed all of your T's and dotted all of your I's. And at this point, we're not concerned about compliance levels. We're concerned about the error messages and what else needs it filling out in the database. Okay, let's close this. Go to the directory window that the output's written to, which is the directory that our input database was in. Open up the validation script. And it says we have some problems, which is not surprising. Okay. We have one term missing in Glossary, one term missing in DataSources. So we didn't stick in data source 2, and we need neatline. In the interest of saving time, I won't ask you to watch me fix all the errors identified by validate database. Know that typically I step through the validation report, fix each of the errors I can see, rerun the validation script, find more errors, fix those until the report comes back clean. At that point, I'm ready to work on symbolization for the map. Pick unit colors, record them in the DMU. I prefer to use the FGDC color set, which is available online. Each of these colors has an identifier, which is in this case a text string, which can be keyed into the DMU. But you can use other symbol values also. If you use the FGDC colors, you can use the symbol to RGB script to get area fill RGB values. Otherwise, you may have to go find an eyedropper in Illustrator or something like that to, or use the ArcStyle Manager to read the RGB values and key those in. So you can use other symbol sets. If you do that, you want to provide the style file with the geodatabase when you give it to others, and you want to document what style you used in the report level metadata. You can then run the set symbol values script, which works with the FGDC symbology to set some line symbols in accord with their attributes, their confidence values, and the map scale. So that if you change the map scale, you simply rerun the set symbols values script, enter a different map scale, and it will change dashed lines to continuous ones if the scale is smaller. It also will set orientation symbols, and in some of those, it will choose to use different symbols depending on what the orientation confidence degrees value is. The mapping of type is concealed, and the confidence values to symbol values is described in the file type fgdc symbol.txt, which is in the resources directory of the GEMS toolbox. And this is that file, and it's got a list of type values and an FGDC symbol identifier. And the FGDC symbols are arranged such that you can, from the identifier for the certain accurate symbol, calculate what the queried certain or queried accurate or certain approximate or queried approximate values are. And this file can be edited to extend the list of types and the symbol numbers in here. This is not a complete set. It's ones that I've had occasion to use. As you run the set symbol value script, it has an option to set label values in map unit polys by conflating the label field in the DMU table with the existence identity confidence field in map unit polys feature class. And the set symbol value script can be run on a runs on a feature data set, and it modifies contacts and faults, orientation points, geologic lines, map unit polys, and you can run it on a cross-section feature data set or on a correlation to map unit diagrams feature data set. When we've done this, we're ready to transition to presentation quality graphics. And for that, we want to move to a new plot file. So we want to save as to a different MXD. We want to change how we symbolize the contacts and faults layer. We delete the fourfold symbolization that we used for digitizing and add contacts and faults as a single layer. Step through each of the layers and set the symbology and mostly we're going to use categories matched to symbols in a style. Pick the symbol field and match it to the FGDC style. If we want to label the map unit polys feature class, we add a new map unit polys layer. We set the symbology to no outline, no fill color, so we're not going to see anything there. We're in a definition query to exclude units we don't want to label and areas that are too small, and then label features with the label field. If we have map units that are to be patterned, we can again clone the map unit polys layer, join it to the DMU via map unit, and symbolize via the area fill pattern description. And that may require some hunting to find area fills that are appropriate for that description. We can get nicely placed dip numbers by first running set plot at scale values, which goes through the structure symbols and looks for the ones that are too close together and picks one and says, don't plot the other. And it does this by setting a plot at scale number, which is the denominator of the map scale at larger than which it's okay to plot that symbol. And so if you put in 500,000, that symbol plots at any scale larger than 1 to 500,000. If you put in 10,000, you've got to zoom in to see it. Once you've done that, run inclination numbers, which calculates where the dip or plunge number ought to be placed, makes a new point and writes the dip number on top of it. And I think that's it. I have done that for this snippet of the Chihuahuacan Forest Southeast Quadrangle. I've turned the polyfill to be 50% transparent, put on top of the LiDAR, and it now looks something like a geologic map.